In this lesson, we're going to look at normalization and how this works within a database. Your starter question is, what is the difference between a flat file database and a relational database? And what are the benefits of a relational database? In this lesson, we're going to be looking at normalization to 3NF, so third normal form. Here are our key words. Question number 1. What are the 3 different entity relationships? Pause the video and write them down. You should have spotted one-to-one, one-to-many and many-to-many. Question number 2. What language is used to query a database? Hopefully you should have noticed SQL. So we started to think about why we need a relational database and reorganizing data so there's no data redundancy. Do you remember we talked about not having duplications of data, and so that data is logically grouped and stored together? Remember our example where we had a customer buying some products. We didn't put that in a flat file table because we'd have some data redundancy, and it made sense for us to have customers in one table and we had products in another and orders in a junction table. This is logically grouping data and is what we call normalization. When we carry out the process of normalization on a database, we can be ensured that the data can be efficiently updated, queried and stored. And there are 3 different stages of normalization: first normal form, second normal form and third normal form. In first normal form, a database will have no repeating attributes or grouped attributes. Here's a table. It's a flat file database which contains data about the courses taken by 4 different A-level students. You can see Bob Jones is taking computer science, maths and physics. Each of those has a different exam board. Each of them has a different teacher. In this form, there are several fields which contain grouped attributes: computer science, maths and physics, for example. Grouping attributes like this makes searching really challenging, and we would never want a database looking in this format. If you wanted to find all the students that take computer science, you couldn't just run a query. And in this instance, the SQL would look like select star, which is the wildcard, so selecting all from students, where the course equals computer science. You couldn't do that because the course actually contains several pieces of data. So one alternative would be to reorganize this file as shown in the next image. So this example here, you can say the grouped attributes have now been moved into separate columns. So you can see that Bob Jones now has 3 separate courses, each in a different column. This means it's easier for us to actually query this table and find who is taking computer science. However, there's still an issue here with the structure of our table and our database. There are actually repeated attributes: course 1, course 2 and course 3. These can also cause problems. So let's imagine a student drops one subject. That would mean we'd have an empty cell, or an empty value. Imagine if some students decide they would like to take more than 3 courses. We've then also got a problem. We'd have to completely restructure our database or start adding extra fields in. This is complicated and could cause problems down the line when we start searching for data. Let's pretend we already had a search in place. If you're looking for who takes computer science, you might need to search in 3 different fields. Well, if we've set that search up already and we have to add a 4th field in for course 4, we've got to change our query to do the search. So the normalization process actually tries to resolve and remove these issues. So the process of normalization, and the first step in normalizing a database, is making sure it's fully efficient. So remember, our definition of first normal form is it has no repeating attributes or grouped attributes as well. Just put it into first normal form. All we need to do is simply increase the number of records so that the attributes are no longer grouped or repeated. So you can see what we've done here. Bob Jones now has 3 different records, one for computer science, one for maths, and one for physics. This table is much easily queried because we can find a single piece of data. So for example, if a student drops a course, we could just delete that record. There'd be no instances of empty fields or no need to restructure the table. It's not perfect, it's still a flat file database though, and it contains a lot of redundancy. So as we've seen previously with flat file databases, we've still got the same details in there. So for example, Bob Jones appears 3 times, his gender appears 3 times, and his GCSE score appears 3 times. So now let's have a look at second normal form. So a database will be in second normal form if it's already in first normal form and where none of its key attributes, the columns or the fields, are dependent or related to the primary key. So here you can see, as we previously said, Bob Jones has been manually written in 3 different times, which is again not good practice. It's that flat file database. We could make mistakes, and this could mean a spelling error could cause the data to be unsearchable. More storage is also required to duplicate this data. So to overcome this problem, we can split this table up so that each entity has its own table and we can link them together to form a relational database. This is our second normal form, remember, using something like a junction table. We figure out the different entities, so one table should only hold data about one entity. There should be a primary key, as we've seen before. So in our student table here, each student has their own student ID. In the courses table, each course has its own primary key, course ID. We've used a junction table where we've got a new primary key called enrollment ID with 2 foreign keys, a primary key taken from each of the 2 tables, student ID and course ID. Now this is working and it's looking pretty good. However, if we look at the courses table, it's not in second normal form. A teacher, in theory, could teach several courses. So if a teacher is not dependent on the course ID, we need to split this table further. So you can see what we've actually done here. We've decided to use a separate table for the teachers. So we've removed the teacher name from the course and we've just put the teacher ID into this table. We've got a new table called teacher ID with teacher name in there as well. Now all this database is in second normal form. It was already in first normal form and it's now in a state, for each table that is, of all of its non-key attributes, so the fields, are dependent on or related to the primary key. So if we look at the course ID, we know the course name, the exam board, and there's a foreign key in there, which is the teacher ID, but it's related to that course. So it's in second normal form. Now, sometimes it can be thought that at this stage, a database is in third normal form. But we need to check about if it is in third normal form. So let's think about third normal form. A database will be in third normal form if it's already in second normal form and contains no attributes in addition to the primary key that also depend on another attribute in the table. So in third normal form, all of its attributes are non-transistently dependent on the primary key. Let's have a look at this now. Looking at the course table, we have our primary key, the course ID, and course, exam board and teacher role ID all depend on course ID. They don't depend on any other column. If we look at the enrolment table, the student ID and the course ID both depend on the enrolment ID in this table. They don't depend on any other columns. And the bottom right hand table, the teacher name depends on the teacher ID, so it's linked directly to it. This also doesn't depend on any other columns. There aren't any other columns, so it can't be dependent on any others. However, if we look at the student table, we have the student ID and we have student name, gender, GCSE score, support and date of birth. Well, we could think that support also depends on another column, the GCSE score. Do they need support or intervention? So these two are related to each other and means that support will be linked to GCSE score. So this is not in third normal form. So remember our definition. A database will be in third normal form if it's already in second normal form and contains no attributes in addition to the primary key, remember, that also depend on another attribute in the table. So with our student table, remember that was in second normal form, we can move it into third normal form by splitting the table further. So each table contains no attributes apart from the primary key that depend on another attribute in the table. If we remove the support and the GCSE score, we can actually see we're now in third normal form. So we've got the student's details, so their name, their gender and their date of birth. We've now got a new table which has got their GCSE score in it and whether they need support for a certain subject, whether that's true or false. And this puts it into third normal form. Here's a visualization of the normalization process. So in summary, a database in first normal form will be if it has no repeating attributes or grouped attributes. Second normal form is where it is already in first normal form and where all of its non-key attributes are dependent or related to the primary key. And third normal form, a database will be in third normal form if it's already in second normal form and contains no attributes in addition to the primary key, are also dependent on another attribute in the table. Please try these activities in your notes and then we'll have a look at some of the answers.